We'll be doing lead code 226 invert binary tree. This is an easy question on lead code. Now, the way I'm going to explain this question is by just showing you like how it would actually look like. So a step-by-step iteration of how it would be. Now what I want you to do is pay very close attention to the way I'm explaining it, right? This is literally the answer. Like there's the what I'm saying can be directly translated to code and it will essentially just work. So there's nothing complicated about it. We'll consider all the nodes, right? Now when we're at 4, that's our entry point, right? So that's the root. When we're at 4, what do we want to do? We want to swap. If you look at the examples answer, we see that 2 and 7 are swapped, right? The left goes to the right and the right goes to the left. We'll do the same thing for 4, 7 and 2. Then what we will do is we'll also have to consider 2, right? Because even the 2 has children that need to be swapped, and that has to go to 3 and 1. Same goes for 7. We will need to consider the children of 7 and make it 9 and 6, right? Now what am I essentially doing here? The first thing that I'm doing, right? The first thing that I'm doing is I'm given a root or like a node. I'm swapping the children. And then I'm picking the left child and the right child. It doesn't matter the order that you go into in this case, but I'm picking the children and I'm also swapping for them. Now if you've gotten an idea, I'll just give another hint. We have to do this by TFS. So if you've understood this, try to write it out in code. I'm going ahead with the answer now, but all we have to do is we can consider this to be, let's just say, a pre-order traversal. So we will process the node as soon as it comes in, right? So our first step would be, if not root, return. Then we're at our node. So the main thing we will do is root.left, root.right. This is a Python shorthand. If you were doing Java or C, you would have to store it as temporary variables and then perform the swap. But you can just do this in Python. A very useful trick. And that essentially swaps our root.right goes to our left and our root.left goes to our right. That's literally it. That's all I did with that step, nothing more. Then same thing, I'll pick my children, I'll call the same function on it, kind of like how we did the pre-order traversal lead code questions. Call root.left, self dot root.right. Then return the root. Return the root because we will. I'll just show it to you actually. So on the first iteration, right, when we enter the question with 4, we are given 2, we are given 7. On our first iteration, we will say 4, 7, then 2. Now keep in mind that 2 hasn't been swapped yet, right? And our 7 also looks like 6 and 9. But our top part changed, right? So now that we've done this step over here, right? Our swapping, we will go to the left child. So let's just go to the left child first. 7, we'll pick up 7. What we will do for 7 is we'll run the iteration again, right? Because now we are back at the top of the function. That's how the recursion call stack works, right? We'll unwind this until we're done. So we'll go to 7. We'll tell 7, since you're a node, swap your children. That's it. 7 would also go down to 6, but 6 has nothing, so it wouldn't matter. 7 would also go down to 9. It wouldn't matter because it's a leaf. Once we're done with this, we'll come out. We'll be with 2. 2 will also tell its children to move around. That's it, right? Sorry, this was supposed to be 1 and 3. That's how it looks like. Got confused with the answer. Yep. So it would be 3 and 1. It's the same, yeah. And that's literally it. It would also go down to the leaves. It would do nothing at it, because after that it will just say null null, return, right? Hit this check, and we've unwinded from the left now, we've unwinded from the right now, and our root will be intact, because we've all made all these changes independent of the root. And that's literally it. So if I had to highlight this second iteration, and that's literally it. Now there's nothing more to it. If actually you could attempt this with BFS, it would make it a bit more complicated. I didn't try it with BFS, but you could do it with BFS. It would just make it more complicated. But another question that you can try out if you wanted to learn more about these traversals. So obviously the 3 traversals, you can search them up independently on LeetCode. Just type it in the search bar, it will come up. After that, there is the zigzag traversal. This one is also a very good one. It will tell you to go left to right on the level, and then right to left. So kind of like how you would read this tree. So you would go 4, then you would go 7, you would go 2 7, and then you would go 6 9 1 3, right? So you're essentially doing like this, like a Z. And it's a very good question as well. You should try it out. And that's it for today. Thank you.